This first chapter, chapter 0, is not in the textbook that we'll be using, but it still has some important things that we'll need to talk about, including standards of measurement, dimensional analysis, conversion of units, and those will be important as we move forward, just that you have those skills, some of which are mathematical skills, but also some of which are just that you need to know how science is conducted. First are standards of length, mass, and time. When one measures a physical quantity, they're comparing an unknown quantity to a known quantity. And this known measurement, or this known quantity, they're called standards. And three properties are required for a good standard. First, they must be accurate. You want a standard that is appropriate for your measurement. So, for example, if you want to measure the width of your human hair, then you need a standard that is appropriate to measure the width of your human hair. That is something that is accurate to such distances, very small distances. Second is that you want a standard that is unchanging. And this turns out to be more difficult than it seems, that you have a standard that doesn't change with time. So for example, if you have a metal ruler as your standard for a meter, for example, then that ruler changes depending on the temperature or the location. It might get longer or shorter. And if you have a standard that is changing, then that's not very useful for making consistent measurements. And then third is that it needs to be accessible to all people. If it's not accessible, then scientists around the world can't use that standard. It doesn't mean that the standard has to be commonly found, but it definitely has to be accessible to all people. Now, just as an aside, we're going to be using the SI system of measurements. The SI system is the international system, or is actually French for like a Système International, I think. You might know it as the metric system, and in particular, we'll be using the MKS system. MKS, this is versus the CGS. These are two subsystems within the SI system. MKS means meters, kilograms, and seconds, and then the CGS means centimeters, grams, and seconds. MKS is what we'll be using, and that's typically used in physics. And then the CGS system is sometimes used in healthcare. So for example, a cc is a cubic centimeter, so that's using the CGS system. It's often used in astronomy for some reason, I'm not sure why, and then also sometimes in chemistry the CGS system is used. I also want to just point out that we'll use scientific notation, and I'm not going to go in depth in this. I think it's something that you know how to do, but in scientific notation, we'll have numbers, for example, 3 million, or actually 300 million is the same as 3 times 10 to the 8th. We'll see that in just a bit. So for length, the current unit of measurement is the meter. That is what we use in the SI system, and the standard has changed over time. That is, we've had different standards at different times in history. In 1799, the standard was 1/10,000,000th. The distance from the equator to the North Pole. And if we think about those three requirements for standards, that is it accurate? Is this accurate? Can you use this standard to measure, say, the width of the human hair or the diameter of an atom? No, it's not accurate to measure those very small distances. Is it unchanging? Not unchanging either. That it actually depends very closely on the shape of the Earth at a particular time, and we know now that the shape of the Earth actually does change depending on the position of the moon, and then also where you measure that distance from the equator to the North Pole. It is accessible to everyone, so it's got that going for it at least. Until 1960, it was a bar in France, the standard. And not like a bar like, hey bartender, give me a drink, but a bar like there was a metal bar that they kept in a vault tucked away, and that was the meter. And all around the world, if you needed to know what a meter was, you would have to reference it back to that particular bar. Not unchanging for reasons that we talked about. Like, for example, if the temperature of that bar changes, it's going to expand or contract. Or excuse me, not accurate, not unchanging, actually. So not able to, you can't use this to measure very, very small distances, like the width of an atom. It changes with time. And third, also not accessible. Now, the standard is the distance that light travels. In a certain amount of time. And that time is 1 over 3 times 10 to the 8th. And I showed you up here what that means, that scientific notation, that it's a 3 with 8 zeros behind it. And we'll use scientific notation throughout the class. This is very good. It is very accurate that the distance that light travels in this amount of time is very, very short. So that means that you can use this standard to measure very, very small distances. You can also use it to measure very, very long distances. It is unchanging. As far as we know, the speed of light does not change with time, and it is accessible to everyone. In fact, measuring the speed of light is a very simple experiment. It's done in most undergraduate physics curriculums.